All right, this is going to be your study guide for the Unit 2 test on Pythagorean theorem, and this is only on Pythagorean theorem. There's really one concept that you need to have mastered here, and there's a couple different ways we use the Pythagorean theorem. So just basic questions starting off like this. If you have a right triangle, and it has to be a right triangle, and this is 5, and this is 7, we're going to say units in this case. How many units long is that question mark? The steps that you're going to follow, you're going to say a squared plus b squared equals c squared. That is your formula for the Pythagorean theorem. If it's a right triangle, this is going to work every single time. So you're going, after you write the formula, you're going to plug in the numbers starting with the hypotenuse. In this question, the hypotenuse is the longest side. Well, let me rephrase. The hypotenuse is always the longest side, and it's across from the right angle. In this question, the hypotenuse is the one that we're looking for. You're not always going to be looking for the hypotenuse. In this question, we are. So we are looking for C in this case because C is always the longest side, and A and B are the longest side. So I could either put 5 squared plus 7 squared or 7 squared plus 5 squared. I'm going to do 5 squared plus 7 squared equals C squared. That gives us 25 plus 49 is equal to C squared. You do not add those up and put them on the right-hand side. Remember, you're going to keep C on the right-hand side, and you are solving for that C. So now we're going to add these two numbers together. I believe this is going to be, what, 74 is equal to C squared. And to get that C by itself, we've got to do the inverse operation, or we got to do the opposite of squaring something. We're going to take the square root of C squared, and that's going to be, we're going to be left with C by itself. And if we take the square root of the right, we got to take the square root of the left. So C is equal to the square root of 74. If it said leave your answer as the exact answer, your answer is the square root of 74. If it says round to the nearest tenth, you have to figure out what that is to the nearest tenth of a number. You got to figure out what the whole number would be and then the first decimal after that. So the square root of 74 is in between the square root of 64, the square root of 81. I don't know, what is it? 64 and 81. Let's say it's about 8.6 or something like that. I don't know off the top of my head. You're going to have a calculator with you. That looks like it to be about a pretty good guess. And then the last thing that you're going to do is you're going to ask yourself, does this look reasonable? Does 8.6 look like it could be about the hypotenuse of that right triangle? Well, it's the bigger number, so it's got to be the biggest side, so that looks good, and the number looks reasonable. If I got 28.6 right there, that does not look reasonable. You want to go back and check your work to see if you did something wrong, okay? Another Pythagorean theorem question that might come up looks something like this. And if this is, let's say this is 8 and this is 15, how much would this be? Okay, so we're going to answer this question the same way we answer to begin with every time. Write down the formula. Plug in the number starting with the hypotenuse. We want to identify the hypotenuse because in this question, the hypotenuse is 15. All right, so we're going to do 15 squared. We know that because it's across from the right angle. So we could either put 8 in for A or for B. Doesn't matter. In this question, we're going to solve for B. So we have 8 squared plus 15 squared. 8 squared plus B squared equals 15 squared. We know that this is going to be different because we're solving for a leg now. So we've got 64 plus B squared is equal to 225. And I like to do the boxes here just to kind of organize things for us. I'm going to leave B squared in this side. We're going to have 225. When we change the side, we're going to change the sign. Subtract 64. All right, now your B squared comes right down because you are not combining it with anything. It's going to come right down there, and it's going to be B squared. All right, and then 225 minus 64, what is that, 161. And this is not a perfect square, so when we take the square root of this, we're going to get the square root of a non-perfect square. Square root of b squared is just b. If we wanted to write it as our exact answer, we'd leave the square root of 161. Square root of 161, it's 12.7 or something. We're going to say it's approximately 12.7. All right, those are just your basic types of Pythagorean theorem questions. Guys, if you don't identify the hypotenuse, if you put that in the wrong spot, that's going to make a big difference. You're going to get the whole thing wrong. All right, let's look at the dots. We've looked at this before. We've proven that the distance from here to here is not the same as the distance from here to here. I know it looks like it. You count the spaces, not the dots. But the distance from here to here is not the same, because if I made it into a right triangle, here's your right angle, this is 1, this is 1, this would be 1 squared plus 1 squared. This is going to be the square root of 2, all right, just without doing the math. So if you have, anytime you have the dots, if you have a crookedy line, you have to make it into the sides of a right triangle. Or let me say that again. You have to make it into a right triangle. You have to draw right the legs of the right triangle. You're making this into the hypotenuse. You could have gone up and then to the left. I'll show you what we could have done in just a little bit. So we're going to write a squared plus b squared equals c squared. We're going to now say, I know that c is the one I'm looking for. I've identified my hypotenuse, and there's a right angle right here. The distance from here to here, I'm talking about the vertical line right here. The distance, you count the spaces, not the dots. This is going to be 2, so I'm going to label that as 2 squared. And then 1, 2, 3, 4, 5. This is going to be 5. You count the spaces, not the dots. So that's 2 squared plus 5 squared. It's going to be 2 squared is 4. 5 squared is 25. That's going to be equal to c squared. Is this 29 is equal to c squared. Take the square root of 29, that's going to be our answer. And the square root of 29 is just after 5, so I'd say it's about 5.4, something like that. All right. Does it look like it could be 5.4? Yeah, it looks pretty reasonable. There's 5. This line looks just past that. So if you have a crookedy line in the dots, you cannot tell just by what it's looking at, just by looking at it. All right. Having said that, you're going to be given 2 ordered pairs. Let's just say we're given the pair 7, 1, and we want to find the distance between that point and the point -3, 2. Anytime it says distance or length or how far is it, you are going to want to use the Pythagorean theorem. Now, the coordinate plane may or may not be given to you in this question. You would probably have to flip through your test, look for a coordinate plane, and then plot the points and follow all the steps you know how to do. This question, 7, 1, 1, 2, 3, 4, 5, 6, 7, 1 is right here. And then -3, +2, 1, 2, 3, 1, 2. Those are your 2 ordered pairs, so I'm going to put a segment in between them. Oh, that's a bad segment. Kind of far apart, so it looks something like that. I know that it doesn't look like, I mean, I know this looks kind of hard. Here, let me do this. What's difficult about this is that they are only one away, so it looks pretty skinny. All right, so the distance, we can make this into a right triangle. We could go from here to here, or we could have gone up and then to the left. The distance from here down is 1 unit. That's going to be 1 squared. The distance over, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. So that'd be 10 squared. That'd be equal to c squared. Okay? Since it's only off by just a little bit, you know, you're only going down 1 time, or up 1 time from wherever you are. You have one of the side lengths being 1. So it's you are not going to do any sort of other crookedy line. You're going to go straight up and down or straight left and right to make your right triangle. All right, so 1 squared is 1, 10 squared is 100. You get c squared. I'm guessing that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's be 10. Yep. And then we're going to say 101 is equal to c squared. You take the square root of both sides, and c is the square root of 101. That is going to be a number just past 10. This has got to be about 10.1. All right, units. Anytime you are given any sort of crookedy line, you make it into the hypotenuse of a right triangle. All right, a few more concepts that we need to go over here. You're given a right triangle. The formula does not say a plus b equals c. It says a squared plus b squared equals c squared, and here's why. If you take the side length here and you were to square it, and you take the side length here and you were to square it, the area of those squares is going to equal the area of this square here. So, for instance, I know if this is a 15, and I know that this is a 7, the area of this square has to be 15 plus 7. It doesn't say a plus b equals c. It says a squared plus b squared equals c squared. This has got to give you 22. And if you're finding the length of the side of this triangle, if you're trying to figure out what this length is, it's the square root of 22. And you just round that to the nearest tenth. So that's a 15, that's a 7, that's got to be a 22. Furthermore, let's say those aren't given to you. Let's say this is 51. And let's say that this is 7. The area of that square that's missing plus the 7 has to equal 51. All right? This area right here plus 7 has to equal the area of this square right here, which is 51. All right? So there you would subtract. You get 44. The area of this square is 44, so the side length would be the square root of 44. The area of this side length is 7, or the area of this square is 7, so the side length must be the square root of 7. The area of the big square here is 51. So if the formula is a squared plus b squared equals c squared, in this case a squared would be 44. B squared would be 7, because this is b squared is the 7, and then c squared would be 51. All right, and to figure out what a, b, and c are, you would just take the square roots, okay? If I could think of anything more that y'all need to know for this test, I will definitely add it. If not, look at those. Look at the worksheet that I gave you, or look at all the, the assignments that I've given you. Look at your notes, look at your do-nows. Y'all do just fine, okay? Good luck.